All right, so the truth value of a conditional statement is either true or false, right? So that's just determining whether the statement is true or not. So to show the conditional is true, we must show that each time the hypothesis is true, the conclusion is also true. Okay, so for every time the hypothesis happens, the conclusion must follow, right? The conclusion must happen as well. So, and as we've seen before, a counterexample is a way to prove a statement false, right? So a counterexample can be used to show that a conditional with a true hypothesis is false. All right. Now, that's an important thing is we have to make sure in order to use a counterexample, in order to for a counterexample to be valid, the the hypothesis has to be true, right? Okay. So if I say if it's cloudy, it's going to rain, and then I find a sunny day with no clouds in the sky that's where it's not raining, that doesn't prove my initial statement false, right? I'd have to um, come up with an example, a counterexample where it was cloudy, but it didn't in fact rain. Okay. All right. So for these exercises below, it says determine the truth value of each conditional statement below. So number one, if the sidewalks are wet, then it has been raining, right? So uh, for every time the sidewalks are wet, is it true that it must have been raining or that it has been raining, right? And the answer is right, probably not. Yeah, this could be due to sprinklers or maybe someone washing their car on the street. So, so this would not be a true statement, right? All right. And number two, and we mentioned a couple of counterexamples um, for number one. Number two, if a polygon has four congruent angles, then the figure is a square. So what do you think? If a polygon has four congruent angles, then the figure is a square. So can you think of a polygon that has four congruent angles that's not a square? What if it's not a quadrilateral, right? Like what if we had an octagon that had four congruent angles? Um, that wouldn't be a square, right? So that's a counterexample. Now, what would not be a counterexample is like um, a circle or something that's not a polygon, right? Or something that didn't have four congruent angles. So you'd say, well, a triangle, is not a square, but that a triangle that doesn't have four congruent angles. It only has three angles. So, all right. Number three. Oh, let me write this truth value down. Oh, I'm sorry. I just realized that I put the wrong truth value on number one. Sorry, that's false. And so is number two. Number three, if Dan is nearsighted, then Dan needs glasses. So if Dan is nearsighted, does that always follow that he will need glasses? Yeah, I think you could look at this some different ways, but I think for the most part, you know, he could be slightly nearsighted, right, to the point where he doesn't need glasses, right? Need is a strong word, so he could make do without him. I'm a person that is nearsighted, um, and I don't always need glasses, right? I can function fine without glasses. Number four, baseball players are athletes. So here it's a little bit tougher to find our hypothesis and conclusion because we don't have um, our if then, but basically it's if a person is a baseball player, then they are an athlete, right? So is that true? Are all baseball players athletes? Yeah, that's a good question. I would say maybe by definition you could argue that baseball players are all athletes, and so I think you could argue that that's true. You could also, maybe get into the semantics and what is the definition of an athlete, and maybe you can find a baseball player who doesn't fit the athletic mold. But in my opinion, I would say this is true. So, all right. Another thing, is not all baseball players are professional baseball players. So, has everyone that's ever played baseball, would they be considered an athlete? I think you could make a case either way on that one. So, all right. There's definitely some gray area with some of these.